22, which is awesome. Going to be doing some more Leetcode today. I've got a number of problems lined up, kind of like usual. I'm not really sure how much time I have. I've got a kid who's taking a nap, and that's what I'm using as my Leetcode time. So we'll see how far we get. As always, we'll just kind of start doing problems and see what happens. And in just a second, I'm going to pull up my chat on my phone so I can see that in case anybody hops on to hang out. And without further ado, let's switch over to Leetcode. I'm on the very tail end of a cold, so if you see me mute and like hack up a lung, don't worry, I'm almost better, but still recovering from some of that. So as always, if you want anything bigger or smaller, or you need to be able to see it better, please let me know. I can zoom in or zoom out. But without any further ado, let's dive in. We're going to be doing a balanced binary tree problem. So this one starts: given a binary tree, determine if it is height balanced. For this problem, a height balanced tree is defined as a binary tree in which the left and right subtrees of every node differ in height by no more than 1. The balanced subtrees of every node. Okay, so in this case, it is balanced because this has a height of 1 and this has a height of 2. This one is not balanced because 1, 2, 3, and 1. So this to me seems like a pretty straightforward recursive problem. So we're going to go private Boolean is balanced, tree node, left, and we're just going to make them final because why not? Final. Oh, and actually, before we dive in too deep, let's just write out our algorithm. So we're going to one. Base cases are left or right is null. Other child is longer, that is taller than 1. 1b, both are null, return true. So then our next step would be to recurse or get the height, or yeah, that's interesting. So I actually need something, I need a function that returns the height of the binary tree, because just knowing if my child is balanced isn't enough. I need to know, and I apologize, my chat disconnected on my phone. So give me 1 second to try and pull that back up. There we go. Okay, I'm back in chat now. So if I missed anything, I apologize for that. So knowing the height, or knowing if my child is balanced, isn't quite enough. I actually need to know, if it is, if the binary tree that I'm looking at, I need to know the actual height so that I can compare the left and the right. And it's also not enough to just know if the child is balanced, because in this scenario, 3 is balanced, and so is 2 actually, but 1 is not. So I do need to know the height of each leg as I'm going down. So interesting. So let me think through how I want to represent that, because kind of the way to cheat on this would be to throw an exception, or have some way for it to bubble that indicator back up. And I could do that with returning a negative number. So I could say is balanced helper returns an int. Let's just experiment with this for a little bit. Returns height if balanced, otherwise returns -1. So I'm not sure that I love this, but let's start by experimenting with that and just see where it takes us. So final tree node. Oh, so then both are null, return true. Compare the height of the children. If either is height -1, return -1. Otherwise, if height is within 1, return larger depth +1. Because if both of them are within 1, so like here, these are both within 1 because these are the same, and 2 and 3 are within 1. But then at 1, the depth is, for 2, the max depth is 1, 2, 3. So I need to return the larger depth +1. And I think that should do it. So let's give this a shot. So if left is equal to null and right is equal to null, then we're going to return 0. Because, or should that be 0? Or should that be 1? Actually, I don't think it matters, but it depends on if you define a height. Let's see if they define height. Different height constraints. 0 to 5,000. Node value, which doesn't really matter in this case. Okay, it doesn't say. So we'll call this 1, because to me a binary tree with one node in it has a height of 1. So if they're both null, then we're going to return that. Otherwise, we're going to say int left height is equal to nothing. And if left is not equal to null, then we're going to go left, or really, I guess we could say left height is equal to 0, because if it's a null tree, then the height would be 0. Otherwise, left height is balanced helper left.left and left.right. And then int right height is equal to 0. If right is not null, then right height equals is balanced helper right dot left and right dot right. Okay. So then if so now we need to handle child unbalanced. In this case, if left height is equal to -1 or right height is equal to -1, return -1. Because if I've got an unbalanced child, then the tree itself is going to be unbalanced. There's no way for it to recover. I think that's true. The height of the left and right subtrees of every node. So yeah. So if we're unbalanced, the whole tree is unbalanced. Okay, and then so if we get past this point, then if, and I don't know if I need to import math, but really what I want is math.absolute left height, or no. So if I know they're both positive, then I should just be able to go math.absolute left height minus right height is less than 2. Then in this case, we know that we've got a balanced tree. If that's not true, we're going to return -1. If it is true, then if left height is greater than right height, we're going to return left height +1. Else, we're going to return right height +1. Okay, so if they're both null, Then we are balanced, and our height is 1. Yeah, I think that matters. If we are, if left is not null, we're going to get its height. Otherwise, it is 0. If right is not null, we are going to get its height. Otherwise, it's 0. If either of our left or right children are -1, we are unbalanced. And then if the difference in height is less than 2, the absolute value of the difference of height. So if one of these is 1, 2, 3 minus 1, the absolute value of that is going to be 2. But if I flipped it and I did 1 minus 1, 2, 3, that would be -2, and I would still get 2. So that should be correct. And then we're going to return the larger height plus 1. So that should do the trick. So really, what I want to know is int root height equals is balanced helper at root, or really, I need to check if root is not equal to null, or rather, if root is equal to null, return true, else else int, we're going to just make this final, because why not, root dot left and root dot right. And if root height is equal to -1, return false, else return true. And just because it's good practice, we're going to go private static final unbalanced equals -1. That way we don't have to be comparing this magic number. And what happened there? There we go. So this way, negative, it's a way to improve it a little bit. So if we find that we're unbalanced, it's a little bit easier to tell that that's what -1 means, and it's not just an arbitrary random number. So I think that that should do it. Let's give it a shot. And as always, we'll see what compilers we get. Private static final needs a type int. Okay. So it works on one case. Let's try it on another. Works on all of our test cases. So let's go ahead and submit it. See what happens. Ooh, not bad. Okay. Memory usage, or we're faster. We're the fastest Java solution currently, or at least we're on par. Could be that it only goes as granular as milliseconds. Then 38.8 megabytes in memory, which is less than 85%, which is really not bad at all. Let's take a quick look and see if there's anything we can optimize. I really don't think that there is. Because yeah, we need this variable because we're testing this a handful of times. We need right for the same reason. We could go back to this being a magic number, but it's just an int, so I don't really expect that to improve at the order of megabytes. So I think we're going to call that good. Actually, there is one int I can remove here because I don't really care what the value is. I just care if it is unbalanced. So let's just see see what that does. At the point where you're optimizing for an int, yeah, and I think there's just some luck of the draw on where Java winds up in memory, because if I submit it again, yeah. Oh, okay. I'm not sure what changed there, but let me, just out of curiosity. Yeah, okay, so this is one of the catches with running a language, excuse me, a language that does any sort of memory management for you, is that there's some variability here. So my first run was 38.8. My next one was 0.1 megabytes higher. my next one was 0.4 smaller than that, and my next one was 0.9 larger than that. And the code didn't change between like these 3 runs. But Java is just kind of doing its own thing. So let's bounce to the next one. And this is one that I think I am familiar with, but I just wanted to see if there was any kind of variation. So you are given an array prices where prices is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So for example, 7154, and I expect the biggest profit would be 1 in 6. Or so 5. So buying on 1 and selling on 6, and it wants to know the biggest profit. Okay, so this is actually one that I'm familiar with. I occasionally ask this when I'm interviewing candidates myself, so I don't know if that's cheating to, to do it on Leetcode, but let's hammer through it. It's a great exercise, and it's one that I think is pretty common in interviews. So let's go ahead and write out our algorithm. Okay, so we're going to iterate the list of stocks, set initial max profit to 0, set initial, or really I should set this to set initial buy to 0, sell to 1, set initial profit to prices at 0, or really prices at 1 minus prices at 0. Iterate the list, or set initial, set initial profit. So I need to track initial profit to set, I have it in here. I just am spelling things incorrectly, which makes it hard to keep track of stuff. Okay, so we're gonna iterate the list, looking for okay, yeah. So what is, so it's interesting because I do ask this question myself on occasion. So I need to iterate the list and see if there is, and keep track of the current minimum that I've found. And okay, so I need to keep track of my initial buy, my initial sell, and my track current minimum as prices at 0. So this is important because this tells me the smallest value that I've found so far, and it lets me compare my current iteration profit to the maximum profit that I saw at my saved buy and sell. So for example, when I start, my buy is 7, my sell is 1, my profit is -6. And then when I do my first iteration at 1, I find 1, which is smaller than 7. So now I want to set my new minimum as 7, and I want to iterate and see if I find a bigger profit. So when I do my next iteration, I hit 5. Now my profit is 4, which is bigger than -6. And I update my buy sell to be that. I update my max profit to be that. And then I just keep iterating. And I'll have to profit, keep typing that project. I have no idea why. And then and check if max profit is negative and return 0 if it is. Okay, so let's go ahead and hammer this out. So int buy is going to be equal to 0. Int sell is going to be equal to 1. Int max profit is going to be equal to prices at buy, or sell, because your profit is when you sell minus what it costs you, minus prices at buy. Int cur minimum is going to be equal to prices at 0. I think that gets us set up with all the priming that we needed. So then for int I is equal to 1, because we've already primed the pump with our profit and our buy and our sell starting at 0. Then I less than prices.length, I plus plus. And then if, so let me think this through. So now if, or really I need this to be the current curmin index. So that's going to be equal to 0. So then if prices at cur min index is greater than prices at I, then cur min index gets I. And then we can't bother updating. So we've changed our proposed buy. So we don't want to update our buy and our sell at this point. And then our next scenario is if, else if. So if we're keeping our same min, then we want to check if the profit at I is greater than our previous max profit. So if prices at I minus prices at cur min index is greater than max profit, then in this case we want to update our buy and our sell. So our buy is going to be cur min index. Our sell is going to be I, and our max profit is going to be prices at I minus prices at cur min, or really this could just be buy and sell, or sell. I don't know why I keep doing that. Buy, sell minus buy. I think that should do the trick. So now I've iterated the whole list, and if I found any valid profit, I'll know. So then if max profit is less than or equal to 0, return 0, else return max profit. Okay, this seems pretty reasonable. Let's try it. Let's see what kind of compilers we get. Buy. Cannot find symbol buy. Cannot. I am struggling to type cur min index, not cur min index. Okay, so that worked. Let's try it on a few other test cases. Array index out of bounds. Oh. Okay, very clever. So what if prices is less than or is 1? In that case, our profit is 0 because we didn't have an opportunity to sell it. And if prices is 0, if there are no stock, then we are all also at 0. So if prices.length is less than, what do I need? If it's less than 2, return 0, because then I didn't have an opportunity to buy or sell. So let's make sure that handles the one element scenario.
Start narrator dialog. OK, let 10. Best time to exiting narrator.
Okay, so that worked. So 2 milliseconds, which is faster than 65%. Very little memory usage, which is fantastic. Is there anything that would speed this up? Just looking to see if there are any. Happy New Year, new puzzles. Always a good time. Welcome, Jax. Good to have you. And I think I've got a valid solution for this. I am just poking around to see if there's anything I could do that would optimize it. And I don't think that there is. Um, because I have to do both of these. I need this final check, and I'm choosing to handle the profit edge case this way. I could maybe do that a different way, but I think that's pretty good. So just out of curiosity, if I submit it twice, I'm wondering what kind of, yeah, 65, 2 milliseconds. So there must be a Java solution that's a little bit faster, but this is a linear solution, so I think I'm good with that. So with that, I'm going to jump to a third puzzle, which is fun because often I only get to two total during the stream. So this will be a good time. We're actually getting through more than I expected to. And the kids' nap time is still running, so that gives us a little more time to experiment. Okay, so this one is majority element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists. So for this, it's 3 divided by, or that. Okay, so n is always going to be nums.length. We'll always have at least one element. So 2 solutions are coming to me for this one. The first idea would be at least linear and probably linear by, well, maybe we could get it down. Maybe we could get it down to just linear. I'm trying to think through that. So we could use a hash map to track the number or well, let me start jotting down notes. So the first solution I'm coming up with is use a hash map of values to counts. Track current most frequent item at iterate the list, updating values to counts. If new element changes most frequent item, update those pointers, return item that is most frequent or n divided by 2. So that's the first solution I'm thinking of. The other solution, I'm trying to decide if it's worth taking a stab at, because you could sort the array and then you could do some kind of a search to see, or you could, take or jump through the array at certain rates to see if you found the item with the longest consecutive run. But I don't know if that gets you much over just visiting every element. And it might. So if you had a big enough list, you might want to do that, where you could, like I said, sort the array and then jump through by like 10 or 15% of the array to figure out if you found the longest thing. And that might help you determine, you could probably do some kind of heuristic to determine the length of your hop. Like Um, oh, yeah, okay. So every time you you would keep track of the longest run that you've found and then use that to determine how many elements to skip. So if we've sorted the array 1 1 1 2 2 2 2 2 3 3 3 3 3 3. So in this case, I would at first I don't know how many I found, but then as soon as I iterate the first element, I found 1. After the second one, my run is 2. After the third one, my run is 3. So when I find a new element, I know that I can skip ahead 3. Because if I skip ahead 3 and I don't find a 2, then the 2 is not more frequent than 1, and I can skip back. Uh, so so let's do this twice, because why not? We'll do the first solution first, because that to me seems very straightforward. And then if I've still got time left in the stream, I'm looking for how long I've been on. If I still have time, then we'll give it a shot for this kind of hop ahead method and see what we can do. So private int majority element 1 int nums. And I'm just going to shadow the main methods that I have, the ease of doing it twice. So first thing we're going to need is final hash map integer, integer, and this one is going to be value to count. Okay, and then int current most frequent is going to be nums at 0, because starting off, that's just the most frequent one they've found. And then from there, I think we just need to iterate the list. So for int I is equal to 0, I is less than nums.length, I plus plus. And then we need to seed the map. It's going to be our first task here. So let's go ahead and do that. So value to count dot put if absent nums at I and 0 or 1. Let's do 0. And then value to count dot put nums at I, value to count dot get nums at I plus 1. So let's just make this a little bit easier. So int value is going to be nums at I. And then instead of doing the array indexing every time, I can just say it's a value. It doesn't save a whole lot, and it uses a little extra memory, but that's fine. And then I don't want to add to the value that I'm getting. I want to add to the value that I got, or the index that I'm getting. I want to add to the value that I got. Okay, and then so now I've updated my value in my value to count, and now I need to check if I found a new most frequent value. So then if current frequent value, I don't really have a great name for that, but if value to count dot get current most frequent value is less than value to count dot get value, then we're going to update current frequent value gets value. And then at the end, we're going to return current frequent value. And I think that should do the trick. There, I think, will be an optimization we could do in here where if we found a number that is greater than half the size of the array, then we should be able to back out and quit early. But let's just see if the logic holds. And of course, you need to connect your methods together. So majority element 1, nums. Let's try it again. Okay, so let's try it on larger, or on a more variety of input. That one also works. So let's go ahead and submit it. 15 milliseconds, faster than 11%. And I'm guessing that's because we didn't do this optimization yet. So let's check if... So I think let's do it here. So final int threshold equals nums dot, or no, this needs to be an int because the criteria is rounded down greater than 2. The floor of n divided by 2. So in this case, it's 3 more than. Okay, so more than nums.length divided by 2. And here we can say if value to count dot get current frequent value is greater than threshold, we're going to return current frequent value. So this should let us quit out early if the number that we're digging for is front loaded. So 1, 2, 3, 4, 5, 6, 7. So 3. So 1, 2, 3, 4. I don't know that this is really going to improve much, but let's try it. Okay, so it works. So let's go ahead and submit it. Faster than 10%. So it's not better. But I suppose in cases where the value is not front loaded, then you would have the same problem. Or really, you're just adding another check. So, yeah, interesting. Okay, so let's go ahead and try our next solution, which is going to be sorting the array. So sort the array, track the longest run, use the longest run to skip ahead each time. So I could explain that better, but we're going to track the longest run that I found and then use that to index further. And that should help us eliminate a lot of this kind of checking that we're having to do. So the first thing is Java sort integer array, because I don't really have to do all this all that often. So I think it's arrays.sort. I feel like I look this up every time that I stream. Yeah. Okay. So arrays.sort, and it destructively or it modifies the array that you pass in. Okay, so let's get started. So private int majority element 2 int nums. The first thing that we're going to do is arrays.sort nums. So now we need int longest run. It's going to be equal to 1. Am I guaranteed to always have at least one element in the array? Yes. Fantastic. So longest run is going to be 1. Int longest run value is going to be nums at 0. And I think that's all that I need to keep track of. Oh, I should also do int. I'm trying to decide if it's worth re-implementing this bailout logic, but let's not optimize prematurely. So we'll just start with these two values, and we can always add this kind of check in. It's easy enough to add that in later if we want to. Let me get the screen bigger a little bit too. So for int I is equal to 0, I is less than nums dot length I plus plus. And now if so what do we need to what do we need to do here? So if longest run plus I is less than nums dot length, or yeah, what's the scenario we want to do here? So if longest run plus I is less than nums dot length, so this is saying if we have more elements of the array to keep checking, then we should. Okay, so if longest run plus I is less than nums dot length, then if, or no, okay, yeah. So if is less than that, and nums at I is equal to nums at I plus longest run, does that mean that I've actually found a new longest? So if I'm at 3, let's do a sorted array. So if I've got 2, comma 3, comma 3, now let's do 1, 2, 1, 2, and 2. 2 ones and a 2. So at 1, I is 0. So 0 plus 1 is that, and we're good. At the next iteration, I is 1. And there we've got my longest run is 1. And now I'm checking if that one is there. So because I've iterated to a new element, in this scenario, I found a new longest run, and it is yeah, so in this scenario, I found a new longest run, and it's going to be longest. It's going to be longest run gets longest run plus 1, and longest run value is going to be equal to nums at I. And I think that that works. And then I want to set I to I plus longest run, because I know that that's still a valid number. So this is I found an opportunity to skip ahead. And what if I haven't? Because then I think I need to keep track of the okay, so then I think I need to keep track of the current run value equals nums at 0 and int current run start equals 0. Because if I can skip ahead, okay, yeah. And then here I also need to update. How long are we at? Okay, I got about 15 minutes left. This is feeling a little more intricate than I think I was expecting. So let's keep going. Okay, so if I'm updating my longest run, then there's a chance that I've found a new run, but I think I can handle that up here. So if current run value is equal to nums at I, or is not equal to nums at I. So if I'm restarting a new run, then current run value gets nums at I, current run start gets I. So if I'm going to a new run, okay, so this is where I've started a new run. And then I want to update my longest run. So if I'm in the skip ahead scenario, do that. If I am not in a skip ahead scenario, then if or no, I wonder if I need to do this first. Let's get it working. As always, we'll get it working and then we'll talk about ways we can optimize. So if if I am no, I don't think that makes sense yet, because I want to try to hop as far ahead as I can, but I do also need to know. Okay, so this is if I need to restart a run. Here, I know that I can hop ahead, and I am not. That's a special case where I found a new longest run. So what if I what if I can't hop ahead? Then I just need to iterate like I normally would. So in that case, I need to use my current run start and my current run value to see if I am longer than my longest run So if I can't jump ahead, then else if current run start minus I, or no, I minus current run start is greater than longest run, then I want to update longest run gets I minus current run start, and longest run value gets nums at I. So do I need to restart my run? Am I in a position where I can hop ahead? And actually, this I think can be a little bit better. So let's bring this into the if statement. So if I can check way off into the distance, then I should. And if I say if longest run plus, or really nums at longest run plus I is equal to, if nums at longest run plus I is equal to nums at I, then I know that I found a new longest run. Else, I have not found a new longest run, and I just want to skip ahead. So actually, either way, I want to skip ahead if I can. So if way off in the distance is still inside of the array, then if way off in the distance matches, I'm going to update my longest run, and I'm going to skip ahead. Does that work in all of the edge cases? So do I need to worry about... And then this case should handle if... So when I've jumped ahead, I've bumped I way out in the distance, and I'm going to find that I've found a new current run value, and I'm going to update my current run value, and I'm going to update my current run start. Or no, no, that's not valid either. Because in that scenario, I may have skipped past the beginning of a very long run. So I don't think I want to do this. I think I do need to only skip ahead if I found something value the way that if I found something. I think I could take that jump and then walk it back. So I could jump way out in the distance and then come back the closer I get. And then I could do some kind of a sawtooth where you jump out ahead. If you don't find a matching number, you come back and then you sort of walk it in until you're really close. But that might be more complicated than I want to get right now. So let's try that. Console error. What's wrong? Nums less than. Missing a return statement, of course. So here we're going to return longest run value. Let's try that. Okay, so it works on very small examples. And it works on longer examples. Let's submit it and see if it's actually any faster. Array index out of bounds exception. How is that possible? Because if longest run plus I, oh, not plus 1 plus I. It's interesting that that worked. I don't think that would have actually bought us much. Okay. So there's something wrong in here. I wonder if it's this case. Because if I think just to find out, I'm going to copy paste. I'm going to do some copy pasting, which is poor form. But I'm theorizing that that in this case, so if I'm checking way out in advance, then I'm not actually updating for my current value. So I wonder if there's an edge case where I wind up not checking far enough ahead. So let me see if I can't grab this whole input somehow. Okay. Okay, yeah. So let's submit that. See if it's actually any faster. Okay, so we're down from uh, like 15, 16, 17 milliseconds to 2, which is not bad at all. Our memory, I think, is up, but that's kind of expected. Or is it? Not really. 2 meg? What happened? So I'm not really changing too much. What if I submit it again? 45. Yeah, so something that I did in there increased my memory footprint. which I wouldn't think it would be the code that I was running, or the code that I'm not running, I should say. Oh, no, it's this. Because when I sort, maybe arrays.sort behind the scenes does some kind of like memory allocation that isn't obvious on the surface, or isn't obvious from just calling the method. So I think the next optimization that I could do would be to do like a walkback on this value, where if longest run plus I, well, yeah. So it's really, I'm losing the value here of that shortened look back because um, in this scenario, I'm just incrementing by, I'm not jumping ahead at all. And I could come back from that longest run to find a new I. I know that it's not going to be a new longest run, but I need to find the best start or the start of the next new number. Um, so I could pick that number and okay, yeah, let me think that through. So what I should be doing is okay, let's mangle this code a little bit further. So this is really not helpful because I already know that it's not going to be longer. So if it's not, so in this scenario, I have an I that I know I can check. And what I need to do is find the beginning of the number that I just landed in. Because I could be partway through a very long run and missing some of the beginning of that. So really what I want to do is take um, int j is equal to longest run plus I, and then while, or uh, int j is equal to that, int new value is equal to nums at j, and then while nums at j is equal to new value j minus minus, and then at the end I want I to get j. So now I've said I landed somewhere. I don't know when exactly that run is going to begin. So take the value there and walk back until you hit the beginning, but don't come all the way back to current I, because then you're losing the value of doing this check. So let's see if that actually works or if I made it worse. Wrong answer. Okay, let's pause. I've only got a minute or two or a couple minutes left in what I want to stream today. So let me see if there's something obvious. Oh, shoot. Because what, so here's maybe the problem is, um, no. So I was wondering if I might be skipping the end of this run, but if I've already found a better longest run than whatever value I was on, then I don't care. Or, oh, hold on. Or I think I need to jump back one because this would find the beginning, but then I would increment I. So really I want to jump back one further. Maybe. Time limit exceeded. Okay. Wonder if I can get some kind of insight quick. What else would be helpful? Probably current longest. So let's grab longest run. Longest run value. Current run value. Current run start. So that might tell me a little bit more about why I hit an infinite loop. If it's obvious to me, and I'll say the next 2 minutes, we'll fix it. Otherwise, this will be a next time I stream problem. So I equals 500. Longest run was 30. Longest run value is that. What happens if I don't? Or no, shoot, I didn't want to submit it. I just wanted to run it and see the output. 99. Longest run is 497. Longest run value is 233. Current run start is 0. Okay, so what if, I think the mistake I made is, what if my jump, what if I jump twice? And the second time I'm past the value of the current run. So it's not enough to walk it back to the next number. I need to walk all the way back to current run value, right? I think so. Yeah. So I need to walk all the way back to current run value to make sure that I didn't miss, that I didn't jump so far that I missed some value in where I was going. So this is not right. So this needs to be, while nums at j is equal to, excuse me, while nums at j is not equal to current run value, j minus minus, and then I want I to equal, or wait. Okay, so okay. Um, yeah, okay, so interesting. Yeah, I'm gonna keep saying I'm gonna cut myself off, and I haven't yet. Um, so I think what I need to do here is keep track of two numbers. One is the beginning of the next number. I'm gonna check for a longest run, which is the value that was at longest run plus I. And then I also need to keep track or find the end of my current run. So let's have int j value or start of next number. And then we're going to have, or really I could just have that be int start of next value equal, or yeah, I don't have to save it yet. And then this int end of current value. So then we're going to walk j back, but inside of this, so while really this should be while j is greater than I, if int next value, oofda, next value is going to be nums at longest run plus I. So then if nums at j is equal to next value, then start of next value gets j. And then if nums at j, or really this could be an else if nums at j is equal to current run value, should just, yeah, no, I think I do need to test that. Then end of current value, and really this might need to be less than or equal to, because it's possible that I'm on the last value. Then end of current value gets j. Okay, so at the end of this, I want I to get start of next value. I want if current run start, or rather end of current value minus current run start is greater than longest run. Then I want longest run to get end current value minus current run start. And I want longest run value, I think that's what I'm calling it, to get, what was I naming it? Current run value? Yeah, current run value. Okay, that got convoluted, but I think that actually should solve the problem. So if I have not found that I'm that I get to skip ahead, I need to walk back. I need to keep track of the start of the next possible longest run, and I need to figure out where my current value has ended. And then I need to jump ahead. I think that needs to be -1, but that might be, because that could be equal to j. Let's try it. Start of next value might not have been initialized. Sure should have been, but we'll set it to 0. Just keep Java happy. You wind up doing a lot of things as a Java engineer, mostly aimed at keeping Java happy. Bet that's wrong. Or nope. Yeah, time limit exceeded. Start of next value. That feels like I've got something wrong again. Yeah, okay. So I've still got something wrong in this heuristic. I'm actually going to cut myself off there because I'm a little over the time that I was going to spend. But thank you, anybody who stopped by, for hanging out. Much appreciate it. And I will take the problem next time. We'll see if we can make it more efficient than it was.